Hi there, let's get started with Spring Data MongoDB tutorial. This series is targeted towards using Spring Data Framework to perform CRUD operations on MongoDB, which is NoSQL database. If you have used Spring Data before, you can get onboarded to Spring Data MongoDB with no time. This is chapter 1 in the series, in which we are getting basic understanding on NoSQL database, when to use it, and basic hands-on and some myths talked in relation to NoSQL database. NoSQL databases started emerging in late 2000. When people use term NoSQL database, they typically use it to refer any non-relational database. Some says the term NoSQL stands for non-SQL, while others say it stands for not only SQL. Either way, most agree that NoSQL databases are the databases that store data in format other than relational tables. As we know, data came in all shapes and sizes, structured, semi-structured, and polymorphic, and defining schema in advance became nearly impossible. NoSQL databases allow developers to store huge amount of unstructured data, giving them lot of flexibility. NoSQL databases comes in many variants, but here are four main types of NoSQL databases. Document database, key value stores, column-oriented database, and graph databases. In this tutorial, we'll be using MongoDB as a document database. So when you will prefer NoSQL database over SQL databases? So first one is pace of development, because NoSQL databases often allow developers to be in control of structure of the data. They are good fit for the modern agile development practices, which is based on sprints and quick iterations and frequent code changes. Whereas in SQL database, developer must ask to SQL database administrator to change structure of database and then unload and reload data. It can slow down the development. Another reason is like many structured form of data in one database. NoSQL databases are often better suited to store and model structured, semi-structured and unstructured data in one database. Another reason is when you want to access ginormous amount of data. NoSQL databases were created to handle big data as a part of their fundamental architecture. Additional engineering is not required when SQL databases are used to handle web scale applications. The scale of traffic and need for zero downtime. The scale-out strategy used by most NoSQL database provides a clear path to scaling the amount of traffic a database can handle. Scale-out architecture also provides benefits such as being able to upgrade a database or change its structure with zero downtime. New application paradigms can be easily supported. The scalability of NoSQL database allows one database to serve both transactional and analytical workloads from the same database. In SQL database, usually a separate warehouse is used to support analytics. NoSQL databases support polyglot persistence, a practice mixing of various types of NoSQL databases depending on need of particular segments. For example, some applications store most of their data in document database like MongoDB, but supplement that with graph database to capture inherent connections between people and product. Now we understood reason to use NoSQL database. We are good to get started with MongoDB Atlas and Compass. Beginning with MongoDB Atlas. MongoDB Atlas is MongoDB's database as a service. Of course, you can set up MongoDB in local, but using MongoDB Atlas is a better way to get started. It's a suite of integrated data services such as hosting your databases for you on the cloud of your choice. MongoDB Atlas will also scale your databases up and down as required, keeping you available while keeping cost low. It will handle backups, redundancy, and also includes extra features such as chart, text search, app services such as serverless functions, and many more. So we'll be using MongoDB Atlas to set up our database. And once database is set up, we need some form of UI to access data stored in database. So for that purpose, we will be using MongoDB Compass. So this is what UI for MongoDB Compass looks like. Now let's get started with setting up our own MongoDB server. For that purpose, you need MongoDB Atlas account. You can easily create account by using sign up process. Once you have created account, you can move to your project. So here in my case, I am in project 0, and after that click on build database. Here I will choose shared database because this is free. So if I click on create, after that you have to choose which cloud you want to deploy your databases. So in my case, I am just choosing Azure. You can choose anything you want. and then click on finish and close. After this, click on this menu icon and select load sample dataset. And now time to set up our credentials and IP address to connect to database. So for that purpose, you will click on connect. After this, you will get asked for adding connection IP address. You can add your current IP address or a different IP address, or you can just set IP address so that it will just allow all the connections. So this is like least secure way to connect Mongo database and not recommended for production use, but for development purpose I will just selecting like allow access from anywhere. So by default it selects this IP address, and I'll click on add IP address. After that, time to create database user. So here I will create admin and I will auto generate password and click on create database user. After this, you can click on choose connection method. So we'll be using MongoDB Compass to access all of our MongoDB data. So here, once you click on that, it will give you the URL string which you have to use in MongoDB Compass to connect to MongoDB. So I'll just copy this and I will click on close. The user which we created in connect step can be found in database access step. So here you can see the same user and you can edit or change password for that. And IP addresses which we have whitelisted to connect to our database can be found here. So currently IP address is 000, so anyone can connect to this database. It takes a while to load all the sample data in our Mflix database. So I'll just fast forward it to the step where all the data is loaded. Now, as our sample data is completely loaded in database, I will move to MongoDB Compass to connect to this Mongo database. You need to download and install MongoDB Compass application. After installation, when you launch it, you will see UI something like this. Here we'll be entering our MongoDB connection URL, which we copied earlier. And after that, click on connect. After you get successfully connected, you can click on databases to see list of databases present on that URI. You can even click on create database to create new database. On left hand side also you can see list of databases, and if you expand any database you can see collections present in that databases. So here for demo purpose we will be using this sample Mflix database. So in this database we can see movies, comments, sessions and theaters and users collections are present. If I open movies collection, by default it will load all the documents present in collection. So for example here you can see around 23,530 documents are present. So you can see all these documents by default as you scroll. Now let's see how to perform query operations on this data. So now let's get started with sorting data with ascending or descending order using field year. So here you can click on more options. After that, in sort field you can write in curly braces year and order in which you want to sort. So here -1, collection will get started in descending order. If I provide +1, then collection will get started with ascending order. So as you can see, all years are starting from 1891 and after that 93 and so on. And if I do in descending order, so I can see some non-numerical value assigned to this year field, and I want to filter out all the years which don't have this non-numerical value. So for that purpose I will write my query inside this filter criteria. The query closely resembles to JSON data format. So here again I will write like year, then again in curly braces criteria not equal to and value. So which is in this case I can just copy from here. And click on find. So you can see that first 2014 and this non-numeric value got removed. But there are like multiple values, and And if I want to provide array to this not equal to object, then how can I provide? So for that purpose you need to use another operator called as not in. It takes array as the input variables. So I can mention here multiple elements like this 2012, 2012, after that 2011, and so on. So if I click on find again, then you can see all initial elements like 2014, 12 and 11 are not present, and list got started with 2010E. I see there are many documents which has this non-numeric year field. So instead of giving all these years in array, I can use regex pattern to remove all these corrupted documents. So for that I can change this not in operator to not equal. Not, and here I will provide one regex pattern which just checks for this string. And if I click on find, you can see now the list directly starts from 2016 and there are like no non-numeric values assigned to this year field. Now we already removed corrupted documents from our list. We are interested in further filtering our data based upon year. So for example, let's say if we want to have all the documents where year is greater than 2014 and less than 2016, how we will perform that? So initially we assign only one criteria, not equal to this regex separation. So we can add additional criteria to the same field, like movies greater than, let's say, 2014 and less than 2016. So if I click on find, this will give me collections where all the movies are present between 2014 to 16. So you can see it is started with 2015 and only 485 documents are present. And if I keep moving forward, then you can see all the movies are within 2014 to 16. So whatever operators you see over here, for example, not, greater than and less than, so all these operators are applied to this year field. So we can read it as like not equal to this particular value and year is greater than 2014 and less than 2016, and all these operators are comma separate. That means implicitly this operation is considered as AND operation. So it is like year not equal to and greater than and less than 2016. So till now filtration we have conducted on year field. So let's say we want to include one more field in our filtration criteria like IMDb rating. So how we can do that? So for that purpose also we can just simply add one more comma here and include IMDb rating. And here let's say it's greater than 6. And if we click on find, we'll get all the movies which has IMDb rating greater than 6. And same rule applies to over here also, like all comma separated fields are like by default AND operation. And MongoDB Compass provides one nice feature to see a syntax of our queries. So for example, if I click on this, we can check the brackets are properly closed and open or not. So if I click on this, complete here, and even if I select this, it shows what and all queries present in here. So this movies document contains all these details related to movies. For example, title of movies, what are cast in the movies, how it is rated, also languages in which this movie is present. If you notice, value type of this language field is array. So how can you apply filter for this array? So for that purpose, we'll take one more example. So we'll enhance our query to find movies present in three languages. So for that, again I will add comma and new field over here, languages, and same syntax, size 3. And if I click on find, you can see we got 20 documents returned back, and in all these 20 movies we have languages as 3. Even if I move further and see languages, we can see 3 languages are here. Now let's see if I want to enhance my query further to filter down movies which has Portuguese as one of the languages. So for that purpose I will add here equal to and language name Portuguese. So if I click on find, I got only one document in which out of 3 one of the language is Portuguese. This query is giving us the movie which has at least one language as Portuguese in their languages list. But what if we want to check 2 languages or more languages should be present in the list? So for that purpose, we will use all operator, and this all operator takes the list of movies which we want to look. Like here, let's say Portuguese and Italian. You can see the same result found. And but if I change this Italian to let's say Hindi and click on find, it won't give me any result back because it tries to find these 2 languages should be present in languages list. But what if I want to check all languages should be present as I have provided? So for that purpose, I will use EQ operator over here and values and click on find. So now what it does is like he tries to identify the movies which has all these languages exactly. Even if I remove one language and click on find, it will not able to find because unlike all operator tries to match like these 2 elements should be present in entire list, it tries to match exact all list items matches with whatever list item we have provided. Till now we have seen like all basic queries and how to use AND operator, and as I mentioned all comma separated fields are considered as AND operated by default. But if you want to use OR operator, then you have to follow different syntax. Let's say if I want to find a movie which is present in 3 languages, or IMDb rating is greater than 9. So for that purpose, I will start my syntax with open and close curly braces. It takes array as input element. So I'll type here first element like I am interested in IMDb rating should be greater than 9. And next element languages size 3. And if I click on find button, you can see it returned 1519 results in which languages are either 3 or IMDb rating is greater than 9. As we have seen, find result contains all the fields present in document. What if we want to control over fields returned by find query? So for that purpose we will use this project field. Here we can mention like fields in which we are interested in. So for example, if we are interested in title, then we can just enter title and click on find. So you can see all the results present just contains title and ID. Let's say if I am again interested in IMDb rating, then I can write here IMDb rating, and you can see here IMDb object got populated with rating. Also, if I enter languages, then you can see that new array will also get added here, all the languages. And as I mentioned, this id is present by default. If you don't want this id field, then you can turn off this id. So for that purpose, you need to mention this id field explicitly. So here I will mention id 0. So after this, if I click on find, it should not give id field and only the fields which we have provided. So we use this documents tab to perform all the basic queries, like which use like all simple where clauses and simple fetching of documents from the DB. If you want to perform something more complex, then we have to use this aggregation tab. We can think aggregation as a pipeline in which first one set of operations will be performed on that data, and after that in next stage next set of operations will be performed, and in the end we can perform aggregation of the result. Let's see, I want to see number of records present in database. So for that purpose, I will click on add on stage and I will use here group stage. Here syntax for group operation is provided. ID is null because I'm not interested in particular field, and I'm interested in count operation. Now you can see the end result. There are 23,530 documents present in this collection. So let's enhance this example by adding group by year. So here if I provide year field, then this query will return me result for every year how many records are present. For example, here year 1948 there are 70 movies are present. For 1950 69 movies are present. And if I want to further process this data, I can add next stage to the pipeline. Example match. So this match stage is equivalent to our find query. So here I want to see year in which 1200 movies are returned. So I will mention here count greater than 1200. So as we can see, for year 2013 there are 1220 movies got released, and we can verify this from our documents tab as well. So if I go here and if I remove our old filters and just enter year 2013, click on filter, you can see 1220 records are written, which is same as our aggregation query resulted into. We can consider this aggregation as pipeline, and this pipeline consists of stages. All the documents will flow through these stages sequentially. So for example, here first all the documents will flow through this group stage and it will return result with these values like ID and count. So all data processed by this group stage will be provided to this match stage. These aggregation pipelines are extremely powerful operations in MongoDB. We can use this aggregation pipeline even to join one collection with other collection. So for that purpose, I will just delete this older data. I'll just delete this stage and add a new stage. So this new stage called as lookup. I will copy paste my query here. So here I'm mentioning like from comments collection. So another field is late where I'm defining my local variable. So in pipeline, I'm defining how I want to join one collection with another collection. So here I'm saying I want to join ID field of current collection. So here current collection is movies to movie ID in comments collection. So if I go to this comment collection, you can see this is movie ID is present here. So this signifies this comment is for which movie, and we want to result this value as a new field called as movie comment. So if I see the end result, all the collections will have movie comments present here. I can add one more stage to it, like to identify movies which has one comment. So for that purpose, I will write one more stage called as match stage, and here I will write query movie comments and size 1. So you can see after this the result, we can see all the movies which has at least one comment. So this aggregation pipeline also provides stage for projection, as we saw earlier in our documents tab. So to add projection stage, we have to use project stage and fields which we are interested in. So we are interested in title. After that, IMDb rating. I want to map this field to IMDb rating of document and comment text to movies comments dot text. Movie comment dot text. So we can see it populated all the fields here, like title, rating and comment on that movie. We can use unwind operation to change this array to single elements. So you can consider this as a flat map operation in Java where operation is there. So if I click on unwind and give here path as comment text, you can see the difference. Like in previous stage, this is type of array and 0th element was comment text for that movie, and in this, like, we unwind it to this actual field value. Now that we got initial introduction to MongoDB Atlas and Compass, let's see what's our myths around about Mongo database. So first one is like MongoDB is a JSON database. Actually, MongoDB is a BSON database. JSON and BSON are close cousins, as their nearly identical names imply, but you wouldn't know it by looking at them side by side. JSON or JavaScript object notation is very widely popular standard for data interchange on the web, on which BSON is based. There are several issues that makes JSON less than ideal for usage inside the database. For example, JSON only supports limited number of basic data types. Most notably, JSON lacks support for dates and binary data. JSON objects and properties don't have fixed length, which makes traversal slower. Another most popular myth is MongoDB doesn't support transaction. Actually, MongoDB is an ACID database. It supports atomicity, consistency, isolation, and durability. Read and writes to the primary node are guaranteed to be strongly consistent, and updates to multiple parts of individual document have always been atomic. But since 4.0, MongoDB has supported transaction across multiple documents and collections. Despite support of transaction across the documents, they should be used with care because they have performance cost, and because MongoDB supports rich and hierarchical documents. If your schema is designed correctly, you should not often have updates across the multiple documents. Another myth around is MongoDB doesn't support relationships. In fact, MongoDB supports relation with other collection in terms of aggregation pipeline. Another myth around is MongoDB is insecure. MongoDB uses industry standards for security such as TLS to encrypt data in transit and SHA-256 to authenticate users securely. MongoDB also features client-side field-level encryptions, which allows you to store data in MongoDB so that it is encrypted both in transit and at rest. Another myth around MongoDB is MongoDB loses data. There has been no such incident raised which will support this MongoDB data loss issue. That's all for this tutorial. In this tutorial, we covered how to use MongoDB Atlas and MongoDB Compass to access data from MongoDB. From next session onwards, we'll be using Spring Data MongoDB to connect Mongo database and access data. Thank you.